Hello guys. So this is another video on a second order ordinary differential equation. So we have looked on how to solve mostly first order differential equations. Okay. So for this case, we're saying a second order ordinary differential equation are ordinary equations involving an unknown function and its derivatives up to the second order. Okay. So for this video and the preceding lectures, we'll look strictly on second order derivatives. Okay, so for this case we must understand the general form. So it has a general form in the order of f into x y dy upon dx, comma d squared y upon dx squared equals 0. So this is the general form for these second order derivatives. Okay, so if we solve for the highest derivative, okay, so I'll just write, so solving for the highest derivative, for this case, if we solve for the highest derivative, let me clear this first, right? Clean. Solving for this higher derivative, for this case we are saying dy dx squared should give us f into x y dy dx. Okay, so we have just simply solved for this part. Okay, we have just simply solved for this part. So this is the general form for a second order ordinary differential equation. So another concept we'll be looking on is the order and the degree of a second order differential equation. Basically, we will stick on second order. Remember, we have up to the third order, fourth order, and so much more. And also degrees, we have to the fourth and to the nth term. So we are saying the order of a differential equation is the highest derivative present in that equation. So for us, we will say the highest derivative must equal to 2. Okay, because we're dealing with second order. Remember my video on first order, we had the first order as 1. Okay, so we'll just use example. For this case, as you can see, the order has the top level differentiation. Okay, so I can define this as the top level derivative of this equation. So the top level derivative of this equation, which will equal 2, okay, because it's second order. So for this case, as you can see, the d has been squared, so it has an order 2. And again, for this case, the top level differentiation is 2, so it has an order 2. And again, for this case, has an order 2. Okay, so from there we look the concept on degree of a second order differential equation. So we're saying a degree of a differential equation is the power of the highest order derivative. So we must look initially for an order, then from that order let's determine the degree. Okay, provided the equation is free from radicals and fractional powers. What this means is simply the equation must be a polynomial. Okay, so that's what this statement says. So for this case, we are saying it's the power of the highest order derivative. So the highest order derivative for this differential equation is order 2. Okay, that's the highest derivative because the derivative to this part is just 1, and then we don't have a derivative here, so we have a derivative of 1 and then a derivative of 2. So the highest order derivative is order 2. Okay, but we are saying the degree is the power of the highest order derivative, which is the power of this, so it has a degree 3. Okay, So also confirm this video with my initial video for first order, and while I was introducing ordinary differential equations. Okay, so we have similar case. The differences are mostly the examples. So for this second example, we're saying it has an order 2, but remember, what's the degree? It's the power of the highest order derivative. So if I put brackets and uh, find my order, I should my degree, I should get order 2 degree 1. Okay, because the power here is 1. Okay, so for this case example, we are saying also, we are saying this has an order. The top level derivative here is 2, so it has an order 2, and the power of this top level derivative is 1, so it has a degree 1. Okay, so also for this same case applies, so it has the top level derivative as 2, so it has an order 2 and a degree 2. Okay, because the power is 2. So I'll just give another example where degree is not defined. Okay, we said for a degree, for a differential equation to have a degree, it must have, it must be a polynomial equation, so it shouldn't have any fractional powers or any radicals. Okay, so if we have an equation that has radicals and fractional powers, it means the degree is not defined at that differential equation. For this case, as you can see, these are radical. Okay, so these are radical. So for this radical, it means there's no degree. Okay, okay, I can say degree not defined. Okay, so that's all for this video. So please like, share, and subscribe to my channel, and follow for more.